From as long as we can remember, we have been told that we can't be in two places at once. Well, quantum mechanics disagrees. Yep, that's right. In quantum mechanics, a particle can quite literally be in two places at the same time. Sounds fake, but it's not. And that brings us into the mind-blowing world of quantum mechanics. So, what exactly is quantum mechanics? Well, to understand that, we first need to talk about classical physics. Classical physics can be best described through Newton and falling apples, and the motion is simply predictable. Things take a dramatic turn when quantum comes into play. Where classical physics is calm, quantum mechanics is chaos, and it governs the smallest parts of the universe, smaller than atoms. The way that quantum mechanics functions isn't intuitive, and physicists have wrestled with its concepts for years, while some problems still lay unsolved to this day. The three main topics we will be covering in today's video are superposition, entanglement, and the measurement problem. Let's start with superposition. In quantum mechanics, it is possible to be in two states at the same time, or in other words, a combination of states. Imagine you're flipping a coin, and until you look at it and deduce if it's heads or tails, it is both heads and tails. And that's the beauty of superposition. This is what distinguishes quantum mechanics from classical mechanics, and it has real-world applications. A famous thought experiment by physicist Erwin Schrödinger captions this idea. Let's say there's a cat inside a closed box, and you have no idea if the cat is dead or alive. So until you open it up and look at the cat, it exists in a superposition of both dead and alive at the exact same time. And that exemplifies what superposition truly is. Next, let's talk about entanglement. Albert Einstein, a notable figure in quantum mechanics, studied a lot about entanglement. Entanglement is when two particles become linked, and when one changes, the other does as well, regardless of the distance. Einstein termed this spooky distance, because the why behind it is still unknown. So let's say you have two particles, and they mysteriously become linked, meaning that what one does affects the other instantly, no matter the distance. Let's take an exaggerated scenario here, just to make a point. We'll say that one of the particles is quite literally on the moon, and the other one is here on Earth. These particles, for some unknown reason, have become entangled. And now, even with the thousands of miles of distance, a change in one particle correlates to an immediate change in the other. Crazy, right? But that's quantum mechanics for you. And physicists are still trying to reason out why this bizarre phenomenon even occurs. Finally, let's discuss the measurement problem. Here's a particle, and surrounding it is a wave function. This is possibly one of the weirdest aspects of quantum mechanics, but a particle doesn't decide which state it's in until you, the observer, looks at it. In other words, observation collapses the wave function. So like we talked about with Schrödinger's cat, you don't know the state until a measurement is made and the superposition collapses, leaving you with one state. This phenomenon is also essential to quantum mechanics, and if you want to learn more, stay tuned for my next video on the double slit experiment that focuses on this idea that has been talked about for years. The measurement problem is truly one of a kind. So all of this brings us to the question, why does this matter? I mean, why do we even need quantum mechanics? We have classical physics, and that has been working for decades. So what's the need to introduce quantum to the world? Good question. And it's one that scientists have wagered a lot on. In the past couple of years, startups, organizations, and universities have poured millions of dollars into quantum technologies, and it's predicted to quite literally change the world. Just one of the potential applications of quantum mechanics is the development of the first large-scale quantum computer. This can make leaps in fields like chemistry with drug discovery, computer science with machine learning, and finance with an improvement in financial modeling. Now, there's still a long way to go before all of this can happen, but the foundation is being laid now, and there's hope that quantum mechanics may lead to something truly incredible and change the world of computing in completely unprecedented ways in the future. So today we discuss superposition, entanglement, and measurement, the cornerstones of quantum mechanics, and some of the most important concepts. The topics have been gathering lots of attention, and there's still so much to learn and to explore. If you enjoyed today's video, make sure to subscribe and comment any questions you have down below. I'll see you next time, but until then, thank you so much for watching, and stay tuned for more videos.